Good afternoon and good evening, everyone. Welcome to Fashion for Good's Meet the Innovator event. And thank you so much for joining us today. In the South Asia Meet the Innovators edition, we are bringing together a few cutting-edge innovations in the field of biosynthetics. In this action-packed hour, we not only introduce these technologies, we are also bringing in an expert in the field of biosynthetics to demystify the innovation area as well and talk through the potential impact on the fashion industry. So before we start, we'd love to know the different backgrounds our audience comes from. We'll launch a quick poll and we'll let you choose your background. You can see the polls on your screen. We'll give a minute for everyone to choose. We'll wait a few more seconds. Okay, the poll results are out. That's interesting that we have a really interesting mix of audience over here. 36% are students. 15% of them are working for a brand. 19% of them are really interested in this topic, which is really amazing to know. So we'll close the poll results now. I'm sure you all are eager to know what you will be learning at Meet the Innovators today. So this is the agenda for today. We'll have a short fireside chat with our expert, Sophie Mather, and then we'll introduce you to our innovators, Fabio and Biomize, and we'll open to an audience question and answers where you can ask your questions. Please drop any questions that you may have in the question and answer section, and we'll ask as many as we can, time permitting, at the end of our session. So we have our South Asia innovators, Biomize and Fabio, with us. Welcome. We are excited to have Sophie Mather from Biovation as a keynote speaker for this event. Welcome, Sophie Mather. Sophie Mather is a material futurist, and she's the founder of Biovation and the Microfiber Consortium. Over the last decade, whilst working independently, Sophie has been working in niche and emerging areas of sustainable innovation, such as fiber fragmentation and bio-based resources. Sophie has been a part of the Textile Exchange's Biosynthetics Working Group and WRAP's Clothing Knowledge Hub. Prior to Biovation, she served as the Global Director of Advanced Materials for Nike and has worked extensively on sustainability through innovation, new materials, and technologies. We welcome you again, Sophie. So starting with the most basic questions to set the stage for the event, Sophie, what does biosynthetics mean to you?
Yeah, biosynthetics. Can you all hear me okay?
Yes.
Yeah, great. Biosynthetics. Well, we've got two parts of the word, bio and synthetic. Bio meaning from natural and renewable sources, synthetics, man-made fibres or man-made coming out of it. But what I wanted to do is touch on the definition that we came up with when I was working with the Textile Exchange, because this is one of the key things that we did at the beginning of the working group. So we set on a definition created from either partial or 100% naturally renewable resources for the manufacture into synthetic fibres. So that's what we set on for the term biosynthetics. But what I did want to say is with any word that starts with bio, there's often a lot of confusion. And I think before we get into the conversation today, just really wanting to try and demystify some of that confusion is, you know, when the term starts with bio, people automatically jump to the conclusion it's biodegradable. And we know that there are many bio-based synthetics that are not biodegradable. So there's a lot of confusion around the terminology, a lot of different terms that are used and interjected. So I would say to people, you know, just, you know, be mindful of the definitions that you're using, because there's slight intricacies in what they actually mean. Yeah, so thanks. Great question to kind of kick us off with.
So thank you for the definition. It really sets stage for what biosynthetics means. So how are biopolymers different than the conventional polymers?
Yeah, so when you say how are they different, you know, there's different things that we can look at here. We can look at performance, we can look at sustainability. So I'm going to get into sustainability in a minute, but I wanted to come back to the reasons why I got involved in this area in the first place. So I've been working on this area for, gosh, probably about 13, 14 years now. And the first reason I got involved was because of performance differences that I was finding with the biopolymers. So when we touch on performance differences, you know, one of the things that I was looking at a PA 11, so a nylon 11, and it was the difference in moisture regain that we were finding with that polymer that was really attractive to me. So that really set it aside from a regular nylon. I think also when you start to see the portfolio of different materials coming through today, we're starting to see different performance with regards to things like vegan leathers, different materials, and there's a lot of kind of very attractive elements about their aesthetics, hand feel, performance. So that's kind of more on the performance side and how they're different from conventional polymers. But if we go back a stage and have a look at the sustainable criteria or the sustainable benefits of them, because I think that's probably why a lot of the attendees are on the call today. You know, ultimately, you know, people are switching to and moving to bio-based for supporting climate change. You know, and that needs to be our kind of #1 goal here. So if we look at the Sustainable Development Goal 13, combat climate change, I think this is a great one that we can kind of start to use within this. So what we're wanting to do here is to move away from the use of heavily dependent fossil fuel-based or fossil-based polymers, and that's what we are able to do with using bio-based resources. So the difference there is if we were using a fossil, an oil-based synthetic, you are generating CO2 during the production, whereas if you're looking at renewable resources, you're actually using CO2, generating oxygen. So, you know, really a good place, kind of when we look at the big kind of umbrella benefits, that's really where we should be starting. We spoke in the definition about renewable, and I think here is having a feedstock or a raw material that is annually renewable is really important for us. As populations rise, as we're seeing at phenomenal rates, we need to be able to rely on different sorts of feedstocks going in. So having those annually renewable feedstocks are really important. And we need to make sure that those feedstocks are not competing with land or food, etc. Sorry, I'm talking very quickly here. I have to slow down. There's quite a lot to talk about. But I think what we would say is, you know, when we're looking at the differences between regular polymers or conventional polymers and bio-based, I will always come back to the importance of looking at things like LCAs, so life cycle analysis. So that can really help us identify where the key differences are. We know in things like sustainability, you can address one area at the detriment of another. So what we don't want to be doing is relying heavily on renewable resources if we find that has a detrimental effect in some other area, say, for example, chemistry or water. So it's really important to come back to those LCAs and kind of really determine what we're looking at and how it's beneficial from something else. So yeah, does that answer your question there?
Yeah, that's really interesting, which brings me to another question. So can biopolymers be recycled with regular polymers or plastics?
Yeah, that's kind of the big question I get asked quite a lot, actually. It's not as easy as saying, you know, all biopolymers can be recycled. I think this is very much a case-by-case situation. And I think over the years, what we've seen is a developing portfolio of different biopolymers, and each one of them needs to be looked at in its own situation. So a lot of this is based on what the feedstocks are that go in, what the processing is, and what that end of life or that recycling infrastructure is that it needs to go into. And all those three areas need to marry up to enable it to be recycled. So what we are seeing is some biopolymers are biodegradable, some of them are bio-based but not biodegradable, and those are the ones that ultimately we would like to see in a recycling system. But there is a lot of uncertainty at the moment. I think what I will say is, you know, there's the theoretical, what can in theory be recycled, versus the reality of what realistically can be recycled within the infrastructure landscape that we've got today. And across the globe, we've got many different, recycling systems, infrastructures, sorting, separating, recycling in different ways. So, I would love to be able to give you a definitive answer, but at the moment, I would say it's very much a case-by-case situation. Speak to the supplier, ask them what their recommendations are, and then check that there's the infrastructure there to actually recycle it within. What we don't want to do here is to be producing biopolymers or biosynthetics that end up being downcycled. We want to make sure that we're keeping the value in this system when we're looking at things from this kind of circular approach.
Right. And we hear a lot about microfibers too, and you have worked extensively in this area. So often when we speak of synthetics, we speak of microfibers. How can we curb the problem of microfibers?
Yes, that's the other hat that I wear. I mean, you said at the beginning, yes, I do work with the Microfiber Consortium as well. And I think what we're seeing here is, as a response to that challenge, a lot of people are automatically talking about biodegradable fibres as a solution. It's a lot more complex than that. As we understand more about the topic of fibre fragmentation and microfiber pollution, there's a lot of kind of research coming through that is starting to show that things that we would automatically assume as biodegrading are not necessarily biodegrading. So I would say that, again, this needs to be an area that's treated very carefully. Yes, because biosynthetics don't automatically biodegrade. Things that biodegrade in certain environments don't necessarily biodegrade in the environments that they're landing in. So say, for example, we're seeing there's a couple of key research papers that have come out in the last couple of years that look at the fibres found on seabeds, and only between 8 and 12% of those are synthetic fibres, with the majority being cellulosics, which you would expect to biodegrade. So even those natural fibres or the cellulosics that you would assume would biodegrade are not necessarily breaking down. There is some thoughts around that, but it could be to do with the chemistry, the dye stuffs, the finishing that is applied to those materials, and that could be preventing them from breaking down. But I would say just act with caution. And I don't know whether we've got any suppliers on the call today, but it'd be interesting to see what the suppliers are bringing forwards with regards to solutions in that area. So yeah, quite a complex area. And if anybody wants to have more detailed information about fibre fragmentation or microfibers as it relates to this, please drop me a note. I can talk for quite a while on that topic. Yeah,
I can already see a lot of questions dropping in.
Oh, okay.
So do you see a shift in the industry's usage of materials?
Yes, definitely. I mean, I started presenting on this topic for Textile Exchange probably coming up to 11 years ago, 10, 11 years ago. And at the time we were talking about, a small number of people in a presentation, because they were kind of wanting to understand about the, what does it mean? Do we need to know about this? Now I don't know how big their working group is, but in, that amount of time, we're getting more and more brands coming forwards and interested in this topic. We're also seeing more and more suppliers engaging in this, more industry stakeholders across the industry. So I can't give you any kind of definitive figures, but I'm definitely seeing a shift towards new polymers, new materials, new fibres coming through, which is really, really encouraging. But I think it's going to take that continual drive from the industry and forums such as this to promote it, get the conversation started, to enable it to go forwards. And what I would say is, because it is quite a complex area that requires this connection across various different levels of the supply chain, these sorts of collaborative forums is what's going to move it forwards. So start the conversations in these areas, see who you can partner with, because I think what we have learned so far is no one brand or retailer on their own can put enough behind it to make sure that we get the volumes or the economies of scale, etc. here.
Right, and we are seeing a lot of small and mid-stage startups who are working in biosynthetics. So what do you think are the challenges around scaling these biosynthetic innovations?
Yeah, I think with any innovation, and I think, you know, with a lot of the organizations that go through Fashion for Good, you know, you've got the cost element of it. You know, when you start a new innovation, you've got to go through so many different stages, and getting that investment secured is really important. I think when we also are talking about the clothing industry, to get something to the scale, to the commercial scale that you actually require, that's also a challenge. But I wouldn't say, you know, that's not something that should put people off alone. You know, I think, you know, it's the same in any industry. It's not just the clothing industry. You know, if somebody's got a new technology and it's promising and they've got a really strong value proposition, then yes, go for it. You know, I think that cost alone shouldn't be the barrier. Which kind of leads me on to my next point, is making sure that technology has a really, really clear sustainability proposition. You know, what are the sustainable criteria you're striving for? How does it connect together? You know, making sure that you're not focusing in one area at the detriment of the other one. You know, and what is going to be your plan with regards to supporting what you are expecting your technology to do from a sustainability point of view? So are you planning in LCAs, or, you know, what is it that's going to help prove your technology is actually as you say it is? So I think that's also very important. Maturity of the supporting infrastructure. Sorry, I have got a little list here, but yeah, making sure, you know, again, you're not going to be working in total isolation. Your technology needs to work across a number of different stakeholders, different parts of the industry. So, you know, you are going to have a more difficult job to do if the supporting parts that are going to enable your technology to succeed are not fully mature, or you haven't got the stakeholders in place to bring those together. So perhaps one of the more tricky areas, but again, through forums like this, finding out who those partners are that are going to make sure that your part of that technology is going to really work is important. Time. I think it's always underestimated, you know, the time to go from that initial concept. I think working in innovation, having ideas is the easy part of it, but mapping out what the process is from ideation, concept, proof of concept, etc., all the way through to commercial takes a lot longer than people generally anticipate. But again, you know, we've seen a lot of good technologies come through, so, you know, it is possible. Making sure that there's the consumer drive behind it, you know, always asking the question, you know, why is this going to be important to a brand? Why is it going to be important to a customer on the street? If you can't answer that, then there's probably no point in going forwards. So it's really addressing a challenge that we see. So, you know, we've spoken about some of the challenges at the beginning, but really identifying what your technology does that helps solve those challenges. Yeah, and yeah, I think that's pretty much it as far as challenges. I'm sure there's many others, but those are the kind of quick ones off, you know, off the bat there.
Right, and you spoke about sustainability, its impacts, and what is really required from the industry and from the consumers. So what do you feel needs to change in the industry, and what impacts could it have on?
What needs to change? I think to see this change quicker, or from where we're at today, there probably needs to be a bigger drive with regards to policy, or, you know, country down kind of legislation. You know, big drivers there. There needs to be more incentives and kind of reasons why somebody wants to make that commitment with regards to resource, time, infrastructure, etc. And I think the other thing is testing. You know, there is a massive landscape of, or portfolio of different test methods at the moment. You know, I've got a list here in front of me, I don't know, probably 15, 20. It's very, very confusing. And I think the clothing industry needs to define what are the few key test methods that we are going to use to support this, because what I am seeing is some people are doing a very diligent job of testing very heavily in a certain area. But if you think, you know, if they are targeting their top technology to be biodegradable, and they're doing a lot of work with regards to soil-based biodegradation, but that product ends up in the sea and it's not breaking down, it's not fit for purpose. So it's really fine-tuning what are those methods that we need to work on, how can we streamline as an industry, and how can we make sure that the test methods available are really fit for purpose? Because what we don't want to do is we don't want to spend a lot of money testing in an area that's not 100% fit for purpose. So yeah.
Thank you so much, Sophie. That has cleared, I think, a lot of our doubts on biosynthetics. So I'd like to introduce our innovators and let them speak a little bit about their innovations before we move on to audience questions again. So let me introduce you all Biomize. Biomize technology makes bamboo and agri-waste based granules that are alternates to plastic, are certified home compostable, and can be drawn into textile fibers and fabrics that have fashion, medical, and industrial applications. So Anubhav, welcome, and over to you. You can share your screen and maybe explain
Thank
us
you.
what you're in.
Yeah, thank you, Jyoti. Hello, everyone. Good evening. Let me share the screen and just take you through what we do at Biomize. Yeah. So, hi, good evening, everyone. I am Anubhav Mittal. I am founder of Biocraft Innovation Private Limited. We replace plastics from bamboo. So primarily our challenge is we want to connect a farmer who grows bamboo and we develop this bamboo into an industrial commodity and then connect him to the fashion world and other industrial uses, which replaces plastic. That way there is a larger impact of a growing community, a farmer community, who can also benefit from the industrial applications of our new material. So what basically we are trying to do is we are aggregating cellulose, which is generated in agriculture process after every harvest, or biomass from bamboo, and convert them into material which behave like a thermoplastic polymer. And in the process, we don't use any water. It's a completely mechanical dry process, and there's no discharge of any kind of fossil burning of any kind. Our solution, we use all kind of different sources of cellulose, which are basically aggregating sources. A farmer can convert that into fibers and supply to us, and we convert that into granules. Our granules can then go on a standard plastic machinery. They behave like a synthetic material like polyester or nylon, and can be converted into fabrics, fibers, and other applications of plastic, even packaging. So we basically are industrial granule suppliers to industrial users, and our basic customers are plastic manufacturers and fiber makers. So our first target is to address the market of industrial use of synthetic material and convert that into sustainable plastics. We are cheaper because we use a domestic raw material, which is available in plenty in the country. We can mimic a particular property of a synthetic polymer using a biopolymer formulation that we develop in-house. And we supply to our customers much faster just because our plants are located more closer to our customer. We give certified compostability for every product that we sell. There is a direct impact on the farmers and on the larger society because we do our procurement directly from the certified sources. And our business is scalable because we can mimic a lot of different polymers and different plastics using our formulations. So we support farmers who have a poor quality land, which is not good, suitable for agriculture, which cannot support a regular farming. We help them grow bamboo farms, and our target is to give them at least $3,000 annual income, which is minimum to support for a decent living. We are targeting 50 farmers. We are working with the land, which is degraded land. So we don't compete with agrarian land. And bamboo is a very resilient crop, which can very well grow in such kind of land. We are targeting a 200 acres of land for that. And all these bamboo and agriculture waste, we are trying to create by attaching it to an industrial process, a high value product, so that the farmers don't need to burn these stubbles and other things. And there is a value to it, which farmers can supply to us. And we see that these new materials Once they replace plastic, single-use or synthetics, we see that there is a market that will be at least 50% can be converted into these new material from the present oil-based plastics. So there is a huge scope going forward. So these are some of the products that we have prototyped. So this is what we do at Biomize. IBAS is a brand which works under using bamboo, and our 100% products are compostable products.
Thank you so much, Anubhav. So you showed us a couple of products that Biomize is making at the moment. Can you just name what those products are?
So we are doing bamboo activated charcoal infused compostable fibers. We are also making compostable bamboo crystal infused synthetic polymers that can be single dyed by blending it with cotton. So we get both the benefits of a synthetic fiber as well as a natural fiber. And we are also developing further applications um, of performance-based nylon fiber, which is compostable.
Okay, so like you said, bamboo is known as a bast fiber, and so why make biosynthetics out of bamboo when it can be used as a staple bast fiber?
Yeah. So the good part with bamboo is its availability and its cost. It's abundantly available across the globe, and the extraction is easy. It's a very sustainable crop. It can grow on a degraded land. It doesn't need fertile land. It doesn't need too much of water, and it can be sustainably harvested by a farmer for 25 to 30 years without resowing it. So that basically helps to solve a larger cause of reducing the environment load of supplying these industrial raw materials, and connecting our farmers who are otherwise don't have a proper quality of land to you know grow other high paying cash crops.
Okay, and what do you think are the challenges in entering the textile market?
I think as Sophie has already pointed out, our textile industry is basically the end user just buys a garment. So there is a lot of stages of development that needs to be all integrated, right from the fiber stage to spinning to fabric weaving to processing, and then to garmenting. So there is no single source that can develop this all together. So we all have to be collaborative to develop a particular product or a new material for textile application. And I think that if once that challenge is overcome, these new materials can be more innovations can come in, and we can see a big transformation in textile materials going forward in the future.
Great, and you spoke a lot about how this is affecting the livelihoods of farmers.
Yeah.
Where are you sourcing bamboo from?
So we primarily source from right now from farmers who have already planted a decent number of plantations, and they are right now not able to. I mean, the present set of customers that they have is not a regular customer. So primarily, bamboo in India is used in construction industry. So we try to give them a kind of a sustained and a visibility towards offtake agreement, and accordingly we buy from them. So most of our bamboo is coming from Central India region and Northeast India region.
So you're giving them an opportunity to enter more than one industry and thereby
Absolutely.
increasing their livelihoods, which is really amazing. So is it possible to blend these biosynthetics with other materials?
Yes, absolutely. It can be blended with other materials as well.
Can you like give us an idea of what composition that could be?
That needs to be tried and tested based on what kind of application it's going to go in for. So we can blend it with even oil-based polymers, as well as we can even blend it with other biopolymers to give it a particular performance property, whether it's an antibacterial property or whether it's degradation under marine conditions, or whether it's home compostability conditions, or whether it's an industrial composting conditions, or whether we need elongation, tensile strength, or impact strength. So, and also maybe some kind of if a microfiber has to be produced, I mean, a below 1 linear per filament kind of fiber needs to be produced. So based on all different kind of applications, a different formulation has to be designed for it.
Okay. So it depends a lot on performance, you're saying.
Absolutely.
Before we, I think, before we go to the next question, we'd like to raise a poll. I think the poll should be for compostable materials. Okay, I'll let the poll question come by, and meanwhile, I'll ask you another question. So we spoke of blended materials. Are these compostable?
Yes, I mean, it depends what exactly we are achieving. If a compostable material has to be achieved, then accordingly the ingredients have to be chosen and selected accordingly, and then it has to be tested after final product has been made for compostability, and that has been very well defined in the ISO standards.
Okay, and are compostable materials biodegradable, and vice versa? Are biodegradable materials compostable?
Most of oil-based or all kind of materials are biodegradable. Only thing is that how much time it's going to take. So compostability, as per the standards, has been defined as 90 days for 90%. So until unless we don't fit into that bracket, everything it's not compostable, and it's everything is biodegradable otherwise. So I mean, if it is certified compostable, it has to degrade 90% in 90 days.
Okay, understood. Thank you so much for sharing your thoughts and your innovation, Anubhav. Let's now learn about Fabio. Fabio is another innovator in this space. Fabio offers bioplastic solutions where biodegradable polymers that are made from renewable biomass obtained from waste in the beer, dairy, and sugar industries, as well as food waste and seaweed. These bioplastics can also be made from agricultural waste, used plastic bottles, and other containers using microorganisms. Suganya and Anmol, welcome, and over to you. You can share your screen and explain us a little bit more about your innovation.
Sure. Am I audible?
Yes.
That's great. I'll just take a moment to share my screen. So, yeah, all set. So, yeah, we are Fabio and we make 100% biodegradable plastic resins from organic wastes. So, we started Fabio 2 years back because we believe that the greatest threat to our nature is the belief that someone else will save it. And we wanted to be that someone else and find out a perfect replacement to plastics altogether. And we came across a very innovative biomaterial, which seemingly is the most perfect replacement, and it's known as PHA, can be made from organic wastes. Coming to the problem, one look at the oceans or the streets around you says it all, that recycling is not a very favored solution, and only 5% of the total plastic waste generated is recycled. So we definitely need alternatives. The bottom line is we do need to shift to better materials, but not all the materials are very favored or environmentally favorable, because most of these bioplastics currently, which you are being greenwashed, most of us are being greenwashed to switch to, are based on edible resources, which is why they face a huge competition in terms of the raw materials, because we already know food is a huge challenge all over the world, and we cannot really grow that amount of food to convert it into plastic. Moreover, these plastics are also not completely biodegradable under natural conditions, and they degrade only under certain industrial specified conditions. So at Fabio, we have found a solution to all of these problems. We have found a material that can be made from waste resources from various industries, as Jyoti just spoke about. And we also use 50% less chemicals and water than conventional processes, which also reduces the toxicity levels of these plastics. We also generate value-added byproducts in the process, which can be an added source of revenue for us. The resins that we produce have a similar property, thermomechanical properties similar to conventional polypropylene and polyethylene, are adaptable with current product development machineries, and most importantly, are home and marine compostable under 90 days. So that's what makes it a very good value proposition for our products. Thanks to the physical properties, our products can find an application in various sectors, ranging from textile fibers, flexible packaging, including shopping bags or films, or 3D printing inks. And one more very interesting area is the microbeads in cosmetics, which I know most of us are not aware that most of the cosmetics today also contain microplastics. Coming to the market size, over here, I would like to stress on a very important fact. We are very excited by the fact that while the plastic market is growing just at 3.2%, the bioplastic market is growing continuously at 21.7%. That's almost 7 times the growth rate. And that's what gives us more confidence that consumer behavior is continuously changing and people are readily adopting eco-friendly solutions. Still, a lot needs to be done. Talking about competition, yes, there are a few large-scale PHA manufacturers in the world. And when we compared the properties in terms of strength, barrier, and processing, we are, if not better, at par with most of these companies. And when we compared the price, we are currently at $5, which is much lower than most of these companies. And we believe with scale, we might be able to even come down as low as conventional plastics. Talking about the current stage we are doing our pilot trials by partnering with various industries in India and abroad. We are making a product. So there's a term known as co-development. So what we want to do is take the feedback from these companies and create the product specific for their use. That's what we are doing right now. We are also partnering with raw material suppliers, the major one being AB InBev, which is one of the world's largest beer manufacturers. And we are trying to use their raw materials to convert it into our PHA resins. So over the years, we have crossed several milestones. It was not an easy journey at all. And we are currently at TRL 6 at the prototype stage. By early 2021 or the first quarter, we aim to conclude our pilot trials, have all the approvals in place, and begin raising funds for the scale up to 300 metric ton plant. Along the journey, we have also won several national and international awards, the London Business School UK Clean Tech Challenge being one of the most coveted ones. Of course, all of this has come with a lot of patience and grit, which has been there due to our team. And the main product development person and my co-founders are my two strong pillars of support, Anmol and Rishabh. They are helping me with business and operations respectively. We also have mentors from IIT Bombay and IIT Kanpur on our board. The current stage is that we are at the R&D and product development stage, and we are bootstrapping our way through various grants and government bodies and awards to build the product and the first pilot scale facility. Post that, we will be raising $1.8 million as a seed fund to fund our 300 metric ton plan. And our projections subsequently upon scale up from 300 to 3,000 metric tons show a consistent increase in revenues. So the main sources of revenues would be the PHA resins that we produce, the byproducts in the form of kettle feed that will come out, and also technology licensing, which we feel is a very impactful model for early stage startups. Yes, that's about us. And we are Fabio. We redefine plastic in the sense that not everything that is plastic needs to remain in the nature forever. And that's the main goal. Like we want to create a replacement that can vanish altogether from the nature. Thank you so much. And Jyoti, I'm open for questions now.
Thank you so much, Suganya. So the question that all of us actually have for a long time is, what's the difference between PLA and PHA?
Right. That's a very, like I have been asked this question so many times. And the main difference I would say would be in the compostability conditions. PLA is degradable only under industrial conditions, it requires a temperature above 60 degrees Celsius to degrade, whereas our product can degrade under natural conditions, does not require any special temperature or pressure conditions to biodegrade. The PHA.
Okay, and
yeah,
that's interesting. So you spoke about your feedstock, and so apart from bio waste, what are the other waste streams that you're planning to include in the future? And can you also consider textile waste?
absolutely. I mean, all the waste that is rich in sugars or any form of cellulose or hemicellulose can be included. Textile waste or the discarded cotton can also be used in our process, and we are currently trying to incorporate wastes which are available abundantly. For example, grass straws even. We are trying to scale up our technology to fit those feedstock agnostic kind of technology is being built at our end, so that we don't remain dependent on one kind of feedstock, and we can easily switch to different kinds of feedstock. So that's currently the process of R&D.
Okay. And so can PHA replace synthetic fibers in the textile industry?
Yes, absolutely. So PHAs can be used to create anything starting from, let's say, a T-shirt or wearable fibers. So basically, a credit card sized piece of PHA from will, when flushed down the toilet, will vanish in about 2 weeks. That's the most intriguing property of this polymer, and the properties are most similar to polyester or polypropylene, which is why we feel it will be very suitable for synthetic fibers replacement in the textile industry.
Okay. So I think we'll open for a poll now to our audience.
Yes.
You can see the poll question on your windows. Cities that accept all types of plastic in municipal recycling programs recycle everything they collect, yes or no? We'll wait to hear your answer. And meanwhile, I'll raise another question to Sukanya. So, have you compared your material with conventional materials in terms of impact? We already have the poll results. So, 96% of our audience say no. Sukanya, what do you think?
Yes, absolutely. And I think since we are talking about impact, it becomes all the more relevant that you conducted this poll. That's because most of us feel recycling is a very viable solution, and it has been around quite recently that not bioplastics are not a very viable solution. But over here, I just want to talk about two things. That recycling, already I told you about that. Not all the waste streams can be recycled. Like a plastic loses its properties upon recycling, whereas when you talk about this particular material known as PHA, this upon 6 cycles of extrusions also, the molecular weight remains intact to a much larger extent than conventional polymers. That's something that we have validated, and we believe it can be a much better alternative for recycling as well. And in terms of impact, so what do we understand by impact? So that's a very fundamental question that all of us have. So impact basically means what is your greenhouse gas emissions? Like what are you emitting in the process? How can you increase resource efficiency? And is there any dependency on fossil resources? So to answer all the three, so we do not emit any greenhouse gas emissions. We increase resource efficiency because we use waste streams, and we are also not dependent on fossil resources. We depend only on waste resources from various industries, which makes us much more favorable in terms of impact.
It's good to know that you're revalorizing waste and using it as a feedstock. So I would like to open another poll question to our audience. If a plastic container or package is stamped with a number in a small recycling triangle, it can be recycled. Is that true or false? We'll wait for your answer. So 42% say true and 58% say false. What do you think, Sukanya?
So yeah, the answer is definitely false. We've got a good, we have got an audience who has ample amount of knowledge about the topic. Definitely, So the numbers in the recycling triangles are only to indicate which type of plastic resin the containers are made of, and not all the resins are recycled, mainly due to the economics of recycling. So if you know, recycling facilities are paid by weight and therefore prefer heavier plastics. So plastics like the lightweight polystyrene foams or PVC, they can be recycled in large quantities to reap a high profit. So most programs kind of exclude them. So that's what is a limitation to recycling, I would say. And yeah, that leaves me with the fact that we definitely need more favorable recycling options and also better materials to recycle.
Thank you so much, Suganya, for explaining about PHAs, biomaterials, and what your innovation is doing. So now we open up for questions from the audience. I see we have a lot of questions. I'll start asking them. This is for Sophie, Anubhav, and Suganya. So the first question that I have, I'm just going to read out. So this is for Sophie. Um, how producing biosynthetics will help to stop worldwide plastic pollution? Unfortunately, even any biodegradable synthetics are dangerous for nature due to microplastics.
Yeah, I mean, I don't think, well, plastic pollution is scaling at a tremendous rate anyway. I think we need to do a better job of making sure that we're not disposing it in the wrong places. We can look at more biodegradable and compostable biosynthetics, and we can make sure that when we do develop biosynthetics, we can get them into a recycling waste stream. So I think that's perhaps our most immediate thing that we need to do in this area.
Okay. And this question's for innovators. So how do you measure the sustainability of your products? Sukanya?
Yeah. So we generally use a life cycle analysis to measure the sustainability of our products, as I said. And the LCA takes into account many different factors, such as the energy used in the process, the greenhouse gas emissions, and also the water use. So that's how we measure the sustainability of a product from cradle to grave. Like what is the entire value chain, and what are the energy uses and emissions.
And as well, like to add to this, see a sustainable product, it should be also be connecting a lot of different stakeholders. So during the LCA, we also look into that the how easily the product is replaceable and how easily it can be scaled to replace a particular problem that has been created and how effectively it is solving that problem. So once we have that, I think it becomes a sustainable material compared to just a pure innovation.
Absolutely. There are n number of positive socio-economic impacts of a bioplastic industry, and that needs to be taken into account as well when you compare the sustainability of a product.
Okay. And this question's open to all. So should we be trying to get biosynthetics to break down, or should the concentration be on looping them at end of life for further reuse?
I'll jump in here. I think we need to be keeping the greatest value in the system. And if that means that we need to be looking at recycling systems, then we need to be doing everything we possibly can to make sure that they are recyclable and the infrastructure is there. I'm not saying that, you know, composting or biodegrading is bad, but I think, you know, at the moment we're at this kind of critical state with regards to all the plastics we have on the planet, and you know, purely saying it biodegrades or composts, you know, is not always necessarily the most appropriate solution. So I think it's going to be a combination of both, but I think we always need to be coming back to where is the highest value in the waste stream from that product. And you know, others on the panel might completely disagree with me, and that's what's great about a panel. But anyway,
It's a great thought. Only thing is that textile industry is so globalized that possibly the product is being produced in one part of the world and being used in another part of the world, and then bringing it back for recycling into the back, you know, again the production industry or a supply chain could be very expensive and could be not the right solution. But I mean, nature has never given any material which cannot be composted. I mean, so we need to follow the laws of nature. I think that will be the best way. so that the industry and the society and in fact the impact can be very sustainable across the section, because every producer, whether it's a cotton producer or a bamboo producer, should be always be connected to the supply chain. And and we have seen that as a technologies that plastic, even oil-based plastic, once you try to recycle, it always degrades just because of other chemicals and other processing that has gone into it. So, I mean, that's what we feel that it should be more, the more we remain close to the nature's law, I think that will be the best solution for a long-term sustainability as our populations
Great.
are, yeah, and there is a lot of strain on the environment.
And so there's one more question for Sophie. Um, this is more on microfibers. So what precautions and testing can we implement to ensure that new bio-based material solutions are not contributing to harmful microfiber pollution? What can we learn from the current research in microfiber pollution? So that's two questions.
Yeah, okay, so, sorry, excuse me, shuffling my papers. I'm going back to my list of all the different test methods we have here. What you can do is, you can test for biodegradability in different environments. So if you think that this is going to be a product that the fibres fragment and end up in an aquatic situation, then you can pick from a portfolio of different standards in that area. But I think it's not always as clear cut as that. I think if we go back to the true science of textile manufacturing, what we're trying to do at the Microfiber Consortium is reduce and prevent fibres from fragmenting in the first place. So that's our responsibility, and I think that's what we can really bring to this. And I think that is my one kind of key ask to the industry today, is instead of just kind of saying it's biodegradable, so therefore it's taken care of, but we need to have this portfolio approach where we're designing and engineering materials differently. We're trying to prevent the fibres from coming off in the first place, and we're looking at solutions all the way down the line. So we're looking at filters at various different stages. We're looking at better engineering, and as a worst case scenario, if anything gets through that, then if it's biodegradable and it finds its way into that correct environment with the right microbes to break it down, then yes, that's great. So a multi-leveled kind of approach to that.
Great. And this question is for Fabio. So what quality levels can we receive from renewable sources like PLA, PHA, and PHBV compared to conventional synthetics?
So when we talk about quality levels, I think for fabrics, there are three very important qualities, which is moisture permeability, and definitely the wrinkle resistance and the air permeability. So all these three properties are very comparable, and in some cases with certain blends, it is even better than normal fabrics. So I don't think there is any compromise in terms of the qualities if the product is engineered correctly. And I think it's a wonderful replacement to conventional fabrics.
Okay. So this is again open to both the innovators. How do you trace biotextiles in terms of sustainability in the production chain, and do you rely on certifications?
Yes, I think any product or any new technology that has to come in and replace an existing solution has to be certified for the claims that the technology is making about. So definitely an LCA study, as well as the traceability of all the feedstock, should be very clearly documented, and that gives bring in a lot of confidence in the consumers in terms of the source and in terms of the behavior of the new material in terms of its uses and how to dispose that of.
Okay. And again, to both innovators, sorry, so Kanya, you were saying something?
No, just go ahead.
Okay. Okay. So any transparency on the associated energy uses behind these technologies?
So are they asking for data on the kilowatts of energy consumption in comparison with plastic production?
Yeah, I think it's just a general question on whether there's any transparency on the energy that you're using or resources that you're using.
So obviously energy for our processes are much lesser than conventional fossil fuel based plastics. And in terms of units, I would say even 2 to 3 times lesser than conventional fossil fuel based plastics. And I think Jyoti, just a moment, I would like to answer one question that I see comes in a spectrum. Like I've seen this, that why such technologies are not able to scale up, and what's the reason, what's the main bottleneck. So here I would like to say that the bottleneck is the mindset, and we as humans have the tendency to accept more easier paths than the harder paths. So that's what is stopping most of us from commercializing these technologies, and we need more collaborations in the industry, academia, and the government side to make these technologies scale up to the level that they should be at.
Right. Anubhav, do you want to add to this?
Nope, I'm good. I think, yeah, I agree with all the points that you can agree.
Okay. There's a question about awareness. So how do you raise awareness of biosynthetic benefits to the general public? Sophie, would you like to take this?
Gosh, yes. How do we promote it to them? I think we're seeing consumers getting more and more aware of kind of conscious purchasing. So I think, being transparent with them as much as possible is the only way we can do it. And I think, I've seen over the last like 12, 13 years, it's a continual job of communicating to the industry. And I'd say it's exactly the same to the consumers. Be honest, be transparent, and don't get fed up of repeating, really, and bringing them into it. I think with biosynthetics, what is interesting is because people can understand it, because they can see it growing. It's not like a regular conventional synthetic, which it's test tubes, it's chemicals, which is kind of scary for the consumer. I think there's a really lovely kind of product story in this. And I think if the consumer can understand that and see the kind of transparency all the way through, I think that's perhaps the best way to do it.
Thank you so much. I think we'll take one more question. I'm just scrolling on the questions to see if there's anything we haven't covered. So what do you think is better, recycled polyester or biosynthetics? Anybody who wants to answer that?
I would say, what are you referring to when you say better? It depends who you are, which brand you are, which supplier you are, what you're trying to create. I think you'll always find that there's one that is more fit for purpose. And I wouldn't say one needs to be better than the other, but I think it's coming back to what is the intended purpose and does that product fit that purpose? So again, not wanting to kind of shun the question, but it really is about making sure that things are appropriate for their intended use.
Yeah.
Great. Thank you so much. Thank you so much, Sophie, Anubhav, Suganya, for this very informative session. We hope that this was an informative session for all of you in the audience. Thank you so much, all the panelists, for sharing your knowledge with us. This session is unfortunately coming to an end, though we can keep talking about biosynthetics. We wish you all the best, Anubhav, Suganya, and Anmol, and we hope to see more such innovations changing the face of this industry. And thank you so much for voicing your opinions and promoting biosynthetics, and Sophie Mather. This was really a wonderful Meet the Innovators session. I thoroughly enjoyed it myself. I'm Jyoti from Fashion for Good. And thank you all again for joining us, and have a nice evening.
Thank you. And thank you for everybody's questions.
Bye-bye.
I'm sorry I didn't get to
Thank you, Jyoti.
Okay.